Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. So in our discussion today, we are going to look at the concept of derivatives, and this is going to give us the two, of course, a distinct way of describing derivatives in terms of left and right derivatives respectively. Now, in our last discussion on the concept of derivatives, we said that if you have a function y given as f of x, we can be able to give a derivative, or we can give a derivative of this specific function using the f of x equivalent to f into x plus h minus fx all over h. And this is going to be the condition as the limit over h tends to 0. Now, from this specific discussion, we're going to consider the concept of the values of h, and I've said as h tends to 0. And from our discussion on the concept of limits, we said that if we have a value given in these particular coordinates, we can have the value of an increment in the x direction, either on the positive x given as positive h, or in this particular case, negative h given in this particular order. So the value of h is going to depict a small increment or change in the x axis. And of course, this specific point in the middle, we're going to have this particular value for the origin given as 0. So as these two values tends to 0, for that specific limit, as we said, we're going to have a specific definition that we're going to use in referring to this particular function of f prime of x given as such. So having used this specific demonstration, and therefore we can be, or we can consider two cases whereby we are having the value for h greater than 0. So therefore this is going to be given in terms of the function f prime of x as the limit of h greater than 0 given as such. So this specific variation from the general expression can be given in terms of a right derivative. So the above can be described as a right derivative as long as the limit that I'm trying to mention in this specific case exists. So therefore, this is how we can be able, or this is how we can give a notation for what we refer to as a right derivative in this specific case. So for the second case, we're going to consider a scenario where we're having h smaller than 0. So in this particular case, having considered this specific limit, so long as it exists, then therefore the above function is going to be given in terms of a left derivative. And this can be, of course, demonstrated from the general representation that I've given for this specific change in h for the negative and positive respectively. So as the values of this particular function tends, or these values of h tends to this particular value of 0, then therefore we can be able to describe for this from just our general illustration that this is the right part of this of course coordinate system, and this is the left. So literally we can be able to look at this from this specific perspective. Therefore, as the limit h of course h greater than 0, this is the range of values from 0 to this specific point, and therefore it's going to consist of a right derivative. If the limit of h greater than or 0 greater than h in this specific section, then we're going to have this specific derivative given in this particular notation. Therefore, these are going to consist the left and right derivatives in that particular order. And in our various discussions, we're going to be given a range of values, which of course are going to be values given along this particular point, perhaps in numerical values, and we're going to consider whether that specific function is going to give us a left or right derivative in that particular case. And for various functions that we're going to consider, of course, we can just have a look at a general case. So suppose I have a function like this one given as, sorry for that, so I'm just trying to be more accurate. So we have a function given as such. So these are the two functions which are going to be, or a function that is a combination of the function yx, and then I'm going to have this one y is equals to negative x given in this specific case. So if you try to find the derivatives of this particular function for an increment in h, we're going to see that basically we can define the right and left derivatives using these two specific functions, whereby this specific function is going to have a left derivative and a right derivative in that specific order, so long as that specific limit exists. And as we say, these derivatives are going to be, of course, different for negative value and positive value respectively. That, of course, we're going to see that the derivative of this particular function are going to be described as either existence or non-existence. And of course, we're going to use specific functions, as I've said in our various videos, in order to try and find whether that specific derivative of that function exists in this specific case or not. So kindly check our description boxes for various links of other similar videos, and those are going to assist us comprehend the various discussions we have been having on various topics under the concept of derivative. So that is it for now, guys. Bye, God bless you. Catch us in our next video.